jet stream usually doesn't kick in until we get into late fall and winter. We've had recently this outbreak of severe thunderstorms through Oklahoma and Texas into the Gulf Coast states, something that usually happens.
Exists and the impacts we're already seeing.
Welcome to Weather Extra on CBS News Bay Area. I'm KPIX5 meteorologist Paul Hagan. We use these segments on CBS News Bay Area to do a deeper dive into weather and climate topics, a longer look than we can do within our on-air segments on KPIX. And I want to talk more about El Nino because it continues to look more and more like we are going to be getting into El Nino conditions as we head through the next several months, which has an impact on weather patterns, not just where the warm ocean water that defines El Nino exists over the equatorial Pacific, but around the entire world. And we're already seeing some hints of that. We're seeing an even stronger signal that that warm ocean water is beginning to become even more intense. You can see this stripe that extends away from the coast of South America. On the globe here, we have portrayed sea surface temperature anomalies. So how far above in red and orange, or how far below are these ocean surface temperatures compared to where they ordinarily average out. You can see that stripe of above normal temperatures that does help to define El Nino, but it's only one of a few different factors. Now we have increasing confidence that now that we're in El Nino conditions, we are going to continue to be in El Nino conditions for not just the next several months, but for the next few seasons. High confidence, over 90% confidence that we're going to be remaining in El Nino, not just through the summer and into the fall, but into the winter, which is typically when those El Nino conditions do peak. So let's take the virtual reality bars off of the map here and talk about this criteria. How do we evaluate whether or not El Nino is here? And this is the flow chart that's used by the Climate Prediction Center to make that evaluation. So you start with, is the sea surface temperature anomaly at a certain threshold, 1/2 degree Celsius, which doesn't sound like a lot, but when you're talking about a body of water the size of the Pacific Ocean and that area of warmer than average water, that's a big enough difference to have a big trickle-down effect farther downstream. Then, do you think it's going to stay at that level or get even stronger for not just the next several months, but for the next several seasons? And then you look at, what does the atmosphere look like? Is the presence of that warm ocean water already having an impact with the flow of weather through the atmosphere near where the warm water exists, and even farther away from that, farther around the entire world? So let's take those one by one. El Nino exists because we have seen a change from late January in early February in this area that we monitor for the El Nino conditions, from slightly below average sea surface temperatures, a La Nina event, a brief period of neutral conditions shaded in white, and now the above normal sea surface temperatures taking over. It's just reached that 1/2 degree Celsius threshold, but there's high confidence that we are going to stay in those El Nino conditions. That's the second criteria, because there is a lot of warm water below the surface that's going to bubble up and help to intensify the already abnormally warm conditions in the equatorial Pacific. So again, you can see how brief the period of neutral conditions has been. There's a lot of warm water below the surface that is going to just have an exacerbating impact on how far above normal those temperatures are already. So that's category 2. High confidence it's going to continue. Are we seeing a difference in how the weather is behaving? This gets a little bit more complicated. Usually, the way that the weather flows over the Pacific is what we call a Walker circulation. So usually there is warm water over the Western Pacific and cooler water over the Eastern Pacific off the coast of South America. That means where the warm water is, it tends to feed convection, thunderstorms. This is where the rainforests of much of the Western Pacific exist, because it's typically a rainy pattern on a normal basis. You get sinking air where that cold water exists, but when you put where the warm water in a place where usually there's cold water, you disrupt this Walker circulation. And we're already seeing signs of that. So now we're seeing the showers and thunderstorms developing much farther away, thousands of miles away from where they typically develop. Now you're getting sinking air where usually it rains. Now you're getting thunderstorms developing where it usually doesn't rain. This affects the flow of atmosphere around the entire world. Think of if you just took a stream that was flowing downhill, took a big boulder and dropped it into the middle of that stream, the water has to flow around it. It's going to find a different way to go downhill. The atmosphere is a fluid. That's kind of the stream analogy here. It's going to find a way to flow around that boulder, which is the increased presence of those thunderstorms in a place that they usually are not. And that flows all around the entire world. So we're seeing disruptions that exist already in the form of a very active subtropical jet stream. This is the typical El Nino effect across the United States. This usually happens wintertime with a signal towards wet conditions in the desert Southwest and Southern California. The Bay Area, we talked about this last month, we're typically on the edge of whether or not we get wetter than normal conditions or just near average rainfall. But the active subtropical jet stream usually doesn't kick in until we get into late fall and winter. We've had recently this outbreak of severe thunderstorms through Oklahoma and Texas into the Gulf Coast states, something that usually happens in January, February, maybe March. This time of year, usually that severe weather threat is drifting much farther to the north as we head into early summer. Instead, we have seen this subtropical jet helping to feed those thunderstorm outbreaks months after they usually occur. So even though the peak of these El Nino conditions usually occurs during the wintertime months, especially with that rainy signal towards Southern California, we're already seeing the impact of those developing El Nino conditions in the Pacific. And we have high confidence, not just that 95, 96% confidence that we are going to stay in El Nino conditions all the way through the fall and into the winter, but there's significantly over a 50% chance this is going to be a strong El Nino event, similar to the conditions that we had back in 2015, 2016, 1997, 98, and 1992, 1983. The new long-range outlook from the Climate Prediction Center also just came out. This is for December, January, and February, so that does actually take us into winter. And look, it matches up almost perfectly with what we typically expect of El Nino conditions, wetter than normal conditions for Southern California and the desert Southwest. No strong signal for the Bay Area and the rest of California because, again, things can go either way. One of our wettest winters on record was that winter of 1997-98, but the last strong El Nino, 2015-2016, we had almost exactly normal rainfall around the Bay Area. So it could go either way. It's something we'll continue to evaluate as this latest El Nino event develops. Every one of them is a little bit different. So we're going to have to keep an eye on the latest trends. And of course, climate change is the heavy foot on the accelerator of everything that happens in the atmosphere. We'll be watching that. We'll also be covering other weather topics here on CBS News Bay Area. If you have a weather or climate question that you want to ask us and we can answer here, just email that to us at weatherextra@kpix.cbs.com.
Any creators that are looking to level up their storytelling and their content creation need a website like Artlist.
Artlist played a huge role in how I planned my project.
Along the beach, you're going to just hover around 60 degrees this time of year. That's what happens. And here's the reason. There is that fog in the marine layer already. Sutro Tower is in there somewhere, just are swallowing up Twin Peaks. We're going to see that fog spreading back out across the bay as we head through tonight, but it will dissipate inland quickly. It'll back up to the coast. I'll show you that in future cast by about midday or so. Near average high temperatures tomorrow for one more day, and it's going to be breezy and quite a bit cooler inland Father's Day and Juneteenth. More of a subtle drop in temperature.
Comes as scientists officially confirm that an El Nino weather event has begun. The naturally occurring phenomenon sees warmer water come to the surface of the Pacific Ocean. It pushes heat into the atmosphere and it affects weather all over the world. The researchers say the latest event is gaining strength and could lead to record-breaking temperatures next year. So let's speak to our environment correspondent, Matt McGrath, who's in Cardiff for us. And Matt, just explain the significance of this official confirmation that El Nino has begun.
That's right. Scientists for months have been speculating, growing in confidence that an El Nino event, which happens naturally every 2 to 7 years, was about to form in the Pacific. And today we've had that confirmation coming from the US scientists saying it is actually happening. It's met the threshold for their criteria to declare it, and they're declaring it. And they believe it'll get stronger. It'll run possibly till next spring. And it will have a significant range of impacts around the world, including possibly driving up global temperatures next year to record levels.
And we're expecting that this will create more of these sorts of images we're looking at on the screen: floods, droughts, and extremes of weather. And I'm looking at some of the notes, particularly in winter. That's when it might be at its worst.
That's right. It will be winter when it gets to its peak of the El Nino. It has different impacts in different parts of the world. It tends to make Australia drier, Asia drier, impacts the monsoon, impacts rainfall in southern US states. So it has a variety of impacts around the world. But the likelihood is we will see more storms, we will see more droughts, and we will see likely more wildfires connected indirectly to a globally warming world. The bigger impact, I think, is the fact that this will push up a lot of energy into the atmosphere, and that will drive up global temperatures. And it's likely that next year will be a record year. It could even get close to the 1.5 Celsius temperature threshold that was agreed at Paris by politicians, albeit temporarily. It could push us close to that, which I think would be quite a significant moment and would give us a glimpse, perhaps, of the climate in the future if the world continues to warm in this way.
Inevitably, people will make the connection with climate change. But is this a naturally occurring phenomenon, one that is just made worse by a warming climate?
Absolutely. It is a naturally occurring event, and there have been about 25 of them or so over the last century or so. What's really different this time is that the warmth in the seas are at record levels of warming. Normally, an El Nino comes along and it pushes up the temperature in the seas and then into the atmosphere. But right now, the El Nino is coming on top of record warm temperatures. And scientists say, literally, we are in uncharted territory. We do not know what that will mean. Having this much extra heat come into the atmosphere from already warm waters, we could see significant impacts that we just don't know what they are just yet.
Matt, really good to have that explanation. Thank you, Matt McGrath there in Cardiff. Well, let's talk to BBC Weather's Chris Fawkes. And Chris, you've got some really interesting charts behind you there. Just explain a little bit about what they show, because Matt was explaining this is naturally occurring, but nonetheless, it could have huge implications for our weather right around the world.
Yes, it could have in the months to come, Ben. You're dead right. And El Nino is where we get the warm waters across the tropical Pacific Ocean, this part of the world. And you can see these red colours show that temperatures are indeed above normal. That's why the Americans have been the first to declare that an El Nino is underway, although they do talk about the signal being quite weak. There are other Met agencies, for example, the Bureau of Meteorology in Australia and the Japanese Meteorological Agency. They reckon we're still in neutral conditions. They are forecasting it to become an El Nino, but there are some things in the atmosphere that aren't quite linked in at the moment. The winds aren't quite right across the Pacific, and we've still got some quite warm waters in the west, which you wouldn't normally see in an El Nino. But that said, all agencies are expecting an El Nino to arrive. It's just that the Americans have said it's arrived today.
Chris, just explain that point I was talking to Matt about why we feel this more in winter, and it's to do with the pressure systems being stronger, isn't it? Just explain that if you can.
So it affects the whole planetary circulation via something called the Hadley cell, which kind of moves around, and it moves which parts of the planet see wetter than average weather. For example, over the last few weeks, we've seen some torrential rain in Ecuador here, and that's brought some severe flooding. Same true across Peru. And around the coastline of South America, temperatures in the seas have been 6 degrees above average over the last month, and that's been just pumping extra moisture into the atmosphere. And that is a classic kind of El Nino signal. One of the other things that we can see is much drier weather across Southeast Asia, and this can often really result in more significant wildfires affecting parts of Indonesia, Malaysia. Sometimes we see stories of the smoke drifting across this part of the world and affecting Singapore as well. So there are global impacts from an El Nino event. Some of the other bits and bobs, well, at the moment, the National Hurricane Center is forecasting an average Atlantic hurricane season. But in El Nino years, actually, there tend to be fewer hurricanes in the Atlantic. The reason being there's more wind in the atmosphere. And the one thing that hurricanes hate, ironically, is wind. Kind of blows over the circulation, stops them developing. But at the same time, those warmer waters in the Pacific Ocean tend to produce more storms. So you tend to get more typhoons and more hurricanes in the East Pacific Basin and fewer hurricanes in the Atlantic Basin.
Hurricanes hate wind.
They do. It's one of life's ironies. They kind of work like chimneys, sucking up the energy from the warm seas underneath and then blowing out the winds at the top of the storm system. But these winds kind of blow the hurricane over
update, we're going to be looking at past analogs for past El Nino events and how strong will this El Nino get for the winter season, and how will it influence the upcoming winter for the United States. Now, if you're new to the channel and you really like these detailed updates, please consider subscribing if you're new, hitting the like button, sharing this video with their family and friends on social media, and lastly, please leave an awesome comment in the section below this video. So to start off the video, we're looking at our summary because NOAA has declared an El Nino advisory. This means El Nino conditions are being observed across the eastern equatorial Pacific, so I'm going to highlight that. And we're looking at above average across the east and central Pacific basin with those sea surface temperatures. It is also notably important that atmospheric anomalies are consistent with a weak El Nino that is now in progress. And we're expecting to see El Nino to gradually strengthen and further strengthen into the Northern Hemisphere winter of 2023 and 2024. All right, so this is really important. What I highlighted there on the screen illustrates this is why we have an El Nino advisory, because sea surface temperatures are above normal. The atmospheric is behaving like that of a typical El Nino. So recent evaluations of our equatorial Pacific sea surface temperature departures, we're looking at near to above average sea surface temperatures that have persisted across most of the tropical Pacific basin. Positive sea surface temperature anomalies in the eastern and Pacific basin expanded westward with time. So when we actually highlight this area here, I'm going to get blackout. We can really see how this really has expanded westward over the last few months, which is important, right? That's how we get a atmospheric response to El Nino, is this basin-wide warming that we typically get. May not be as warm in the El Nino 1+2 region, but it is surely warmer than it was a couple of months ago in the Central Pacific. And that is really important. That El Nino 3.4 region, or Nino 3.4, is extremely important because it influences our weather the most during the Northern Hemisphere fall and winter time period. So when we do take a look at those basins here, this is basically kind of that snapshot. And as always, I try to be as detailed and as informative and understanding as possible for you all that are new when you guys watch these updates. So these are different basins, okay? So I highlighted this in black, so the different basins. So when we look at this down here, all right, we can clearly see that. Everyone, can you all see that? I'm sure you all can. So that's this thumbnail, and this shows us the different basins. So when we kind of do connect the dots, or kind of, from one thing to the next, when you were a little kid and your teacher gave you these, not really dot to dot, but connect the dots to the proper area on the paper, right? This is kind of what that is. So the El Nino or Nino 4 region is this over here. It is this yellow area that is highlighted. The El Nino or Nino 3.4 region is this box. Okay, so I'm going to put a box around that so you all can actually see that just fine. All right, and then our Nino 3 region, which is down here, that is going to be this solid red area. So these kind of overlap each other a little bit. And the Nino 1+2 region is this white box right here. All right, I'm going to box that in black so you all could actually see that. So we can kind of get an idea of what our basins are like right now. And the Nino 4 region clearly is warming up. It's already at 0.7 degrees Celsius above the long-term average. The El Nino 4 region is 0.9 Celsius above the long-term average, and the Nino 3 region is 1+2 region above the long-term average. And really the warmest basin of all is going to be your Nino 1+2 region. This is at 2.6 Celsius above normal, which is almost as warm as it was back in April and May. And we will continue to see warming in that basin, let alone over the next few months. So I hope that covered it really well as far as the departures here. So we're going to skip this because this is actually, we could show you this, heck with it, right? More detail, let alone. So we can see, again, our tongue of water anywhere between 1 to 1.5 Celsius over the last 4 weeks. That is significant. Quite warm over here again, along the Peru coast, running 3, even 4 Celsius above normal. There's even some anomalies locally on a daily average that are running 5 Celsius above normal. That is very significant for this early stage in the El Nino period. All right, so let's go to here. All right, so basically this look at the upper ocean heat content anomaly. All right, so this is how much heat content is below the ocean or the surface of the ocean. So subsurface temperature anomalies were negative until June of 2022 before becoming briefly positive. From early July 2022 to mid-February 2023, anomalies were mostly negative. Subsurface anomalies became positive in February and increased through mid-April 2023 before leveling off. Now, here is a very concerning aspect to this discussion that they mentioned here. All right, I'm going to highlight this we'll do red, heck with it, right? Because that's what El Nino means. Since late May 2023, anomalies have slightly increased again. So we can clearly see this reflected in the sea surface temperature anomaly right here. So we have had this huge increase. We kind of dropped down, leveled off, and now we're increasing again. We are now in the threshold that would likely see a strong to very strong El Nino. There's a lot of upper ocean heat content that is well above average below the surface of the ocean, folks. And this is very important. When it's this far above average, look at what our La Nina was like when we had below average heat anomalies below the surface of the ocean. Now we're kind of on the opposite side of things, right? So we've really warmed up quickly, and that is a lot of upper ocean heat content. So we're not going to talk much about this because it's going to be important that we talk about that in this portion of the discussion. All right. So we're just going to kind of look at this later on in the video. All right. Hopefully you all understand that. So our tropical OLR wind anomalies during the last 30 days. So in other words, what we're looking for here is wind anomalies. Are they stronger from the west than usual? Are they stronger from the east than usual? Right. So right now, there have been westerly wind anomalies over the West Pacific, over the Philippines, over portions there of Indonesia, as well as portions there of Taiwan, and even for Thailand and Vietnam. While there has not been much in the way of westerly wind anomalies over the eastern equatorial Pacific in the 850 millibar layer, so this is kind of showing you the low-level trade winds, they have been performing pretty much normal so far. We have had slightly stronger than normal trade wind anomalies in the far eastern equatorial Pacific. So now another thing that we're going to look for here is any upper level wind anomalies. So what we're looking for here is easterly winds. So that means our Walker circulation is weaker than usual. And so far, we are not seeing much of a indication that we are seeing any easterly wind anomalies just yet here. Still a little bit out of the westerly in the 200 millibar layer, which is about 39,000 feet from roughly about 120 degrees west to 80 degrees west longitude. So really, we're only looking at a weak El Nino. That's how the atmosphere is responding at the moment. We're not seeing any indications that the atmosphere is responding to a very strong El Nino just yet. But I'll tell you, weekly heat content evolution in the equatorial Pacific, we're seeing another strong Kelvin wave that is now in progress right now, approaching the international dateline, already sloshing rapidly eastward into the eastern equatorial Pacific. Kelvin waves are very important because they help to slosh that warm water from the western Pacific basin into the eastern equatorial Pacific basin. And so what we're seeing right now is a strong downwelling Kelvin wave that is in progress, and this will lead to more substantial warming in the central and eastern equatorial Pacific in the next couple of months. Wind anomalies, we showed you that, but this is another look at that in better detail. We had strong westerly wind anomalies that were represented from early May all the way through early June. Since early June, we have had stronger than normal trade wind anomalies from the international dateline into the western equatorial Pacific. Still some westerly wind anomalies being represented there in the orange over the eastern equatorial Pacific, which has allowed that El Nino to develop successfully. So we're now going to be looking at this really quickly. Our El Nino is developing quite nicely. Our latest contribution here for March, April, May is 0.1 degrees Celsius above average. We need 3 consecutive overlapping months, 5 of these, to be declared in El Nino. And so far, we're not there just yet, but we're also not far. For reference, we are only about 0.6 degrees Celsius behind 2015, which that El Nino gave us 2.6 Celsius. So give and take, we could still get up to 2 degrees Celsius above the long-term average in the 3-month overlapping mean average, which is very substantial. That is borderline super strong, super El Nino, okay? Actually, no, that's not. My bad. That is actually 2.0 Celsius is a very strong event of an El Nino. And so we are getting there. Just when? How close will we get? How much warming will take place between now and possibly by early to mid-fall? That is to be announced, right? But we are definitely looking at an El Nino, no doubt about it. We have a 95 to almost 100% chance that we will have an El Nino by mid to late fall, by early June. We're already in an El Nino right now. So there is going to be a 95 greater percent chance that we will have an El Nino by fall and winter time of 2023 and 24. Here's a look at the latest IRI guidance, and we can see some of the models are still up here. The second phase of these models are all the way up in that 1.5 to 2.5 range. So we're looking at a strong to possibly very strong El Nino event for this coming fall and winter period. All right, so now that we talked a lot about that, I don't think there's anything more to cover in that PowerPoint. Let's take a look now at our Coral Reef Watch daily 5-kilometer sea surface temperature anomalies. This is delayed by 1 day, by the way. So for you all that are wondering about that, but hey, it's the latest information, right, in this video. So what we're looking at here is a very strong El Nino. Well, to be specific on a daily note, it is pretty well represented here with the orange waters or the orange anomalies, red anomalies. Yeah, we still even have some anomalies here that are 5 Celsius above the long-term average. Repeat with me, everyone, in the video. 5 Celsius above normal. That is sickeningly high. Okay, that is absurd. That is uncharted right there. We have 5 Celsius waters above normal along the Peru coast of Central America. So why is that important, you might ask? Well, that means 1, there's no upwelling of cooler water. And secondly, this kind of gives us an illustration of how strong our El Nino might end up being by the time we go into, say, October, November, December, January, that sort of thing. So these anomalies are actually sloshing eastward with time, and we're already looking at plenty full of warming here with anomalies that are 2 Celsius above the long-term average. There are some anomalies here, some islands that are already 3 Celsius above normal. So that is very, very significant. And so when we take a look here at our movie on the progression of El Nino here for you all that are wondering what this looks like over the last 90 days. So this is since March the 14th. And we can see how this all has progressed over that 90-day period. And yeah, it's definitely developing out there. Some significant warming that has happened recently here. There it is right there. Definitely taking place. We are still seeing that negative look to the PMM or Pacific Meridional Oscillation or something like that. Multi-decadal oscillation, or in other words, we're looking at a negative phase of the PDO or Pacific decadal oscillation along the California coast and the Baja California coast, coherent with this El Nino, which makes this forecast challenging. Now, not going to go much into this. I will have a hurricane outlook and discussion out tomorrow, but my goodness, look at how these Atlantic waters evolve over the last 90 days. Really, really warming up in a hurry here to well above uncharted water territory. And the recent evolution here, 3.5 to almost 4 Celsius above normal there. Look at that red on your screen. There's even a little island there of 4 Celsius right there. You can't miss it. Might be hard to see on your screen, but yeah, definitely very uncharted waters. We'll talk more about that tomorrow as far as this all evolves. So now we're going to go into even cooler data. We're going to look at past analogs, how this El Nino ranks among the others, all the way going back to 1982. So we're going to just kind of work our way across, okay? So this is a look at 1982 and 83. That was a fairly strong El Nino event, right? Of course, we're not even there. We're way warmer than that, as you can see there. Okay, and then let's go to 1997, 1998. What are we seeing here? There is quite the similarity. Pay close attention to this area here on your screen. Very, very similar indeed by anomalies, right? We're actually about as warm as 1997, 1996. Wait, yeah, 1996, 1997, 98. That's what I'm looking for. Yeah, I mean, very, very similar. Only that the PDO up here was above normal. We had a cold phase in the Western Pacific Basin there of the Pacific decadal oscillation, right? But look at the Nino, how that is all evolving here. You can forget about the Atlantic, definitely below average in the 1997-98 period. So let's go to 2015, right? Pretty similar. Again, we're erasing this cold phase of the PDO, which again is why this forecast is so challenging. This is below average here along the California coast. Right over here, it's all above average in the 2015-16 El Nino event, as you all can see clearly here. And so what I'm telling you here is that we are on par of this day of a very strong El Nino, perhaps, that could be emerging capability for the Northern Hemisphere fall and winter time. Okay. So now let's go on to our next thing right here. Let me refresh this. Don't know why their movie freezes up all the time, but this is very, very important. This is looking at that subsurface ocean anomalies, the heat content that is stored below the surface of the ocean. Why is this important? Because it tells us, will El Nino continue or will it just kind of wash away? In this case, it's not going to wash away. We are going to see this continue to strengthen. And this will look literally at the last couple of months. Actually, yeah, the last few months, perhaps, looking at that El Nino. And yeah, look at how this has all evolved since mid-April. All these warm anomalies here just kind of hanging around, no sign of any upwelling at all just yet. We thought there was something going to happen right about in here, but you can see that has since dissipated because of these weaker trade winds. Also pay attention over here too. We've also had some significant warming in the last couple of weeks over in the central and Western Pacific Basin, anywhere between 3 and 4 Celsius above average. And take note recently with what has happened here. We're starting to see a huge Kelvin wave propagate and make its way over into the Eastern Pacific, and it will then get upwelled because of the weaker trade winds. Why is this important? Well, guess what? That's because we're going to start seeing that El Nino really, really take hold. So let's take a look here at our thermocline, and we can see right in here. Yeah, look at that. That is starting to slosh again eastward rapidly. And so it's going to be interesting to see how much warming we will get out of this Kelvin wave that is coming up. If it's going to lead to a more robust warming event in the eastern equatorial Pacific. But look at that, 30 Celsius right now in the central Pacific basin, which is quite concerning to say the least. So now when we take a look at our CFS V2 forecast, how strong will El Nino get from here? Your questions are being asked right now. Still, it looks like we could make rival at least to 2 Celsius. That's what this model actually illustrates. Right now, it's been more corrected from the previous versions. So probably approaching 2 Celsius, which would give us a very strong El Nino event. Okay, 2.5 or higher is super. Okay, super strong. This is more on that very strong type threshold. Take note, the Nino 1.5 to 2 in the 3-month average is a strong El Nino event. So definitely looking at a strong event. Nevertheless, that's going to happen. But I think it might get warmer than what this actually shows because of how far ahead of normal we actually are. We're with 2015, folks, as far as it goes. So that's why some of these members are going possibly up here still, because they are the ones that do think that this is going to go a little higher than what this shows. Some of the members are even indicating the higher end forecasts, 2.3 Celsius above normal, which shouldn't surprise me by any means. So now when we take a look at our climate forecasting system version 2 sea surface temperature anomaly departures here forecast, this is showing us how much stronger will El Nino get. These are 3-month mean averages, folks, okay? Because I want to make this as accurate and honest as possible. That's what I'm here for. I'm not here for the hype by any means. And so we can see here for July, August, and September for our 3-month overlapping mean, we can see how El Nino actually is shaping up. Yeah, that's a very strong signal, folks. That's a really nice looking hot tongue, warm tongue, however you want to say it, there through September. So as we go all the way into, say, through the winter months, for December, January, and February, the peak of the winter months for much of the U.S., yeah, look at that. That is a very nice looking El Nino there, anywhere between about 2.3 to 2.8 Celsius above the long-term average. Yeah, that is quite the reflection there of an El Nino that is yet to come. That is going to strengthen only more. Really warm Atlantic basin for the Atlantic hurricane season. We'll talk more about that later. Sorry, my ears are plugged up. If you're wondering why I do that, yeah, my ears are a little plugged up today because I have allergies. So yeah, don't worry, I'll be better. So when we take a look now at our winter outlook forecast, so I know this is zoomed out, but this is a look at the entire United States right here. You can't miss the map at all. Above average anomalies of rainfall are expected through the peak winter months for January, February, and March. For California, for the desert Southwest, above average rain anomalies, possibly more snowfall storms or snowstorms likely for the southeastern U.S., especially for the Carolinas, northern Georgia. But look at this, below average rain anomalies and precipitation in the form of snow and rain for the upper Midwest, for the Great Lakes, below average snow and rainfall for the Pacific Northwest. Unfortunately, you've had a tough couple of winters. This last winter, you had below average rainfall, snowfall. This winter will likely end up being the same way. So just not getting a good period here for the Pacific Northwest, okay, because of that El Nino that is developing. But good news for California, for the desert Southwest, more needed rainfall is on the way. We can take what we can get, folks, and that's what this is all about. This El Nino is probably going to be good news. Even for November through January, an early start to the winter season looks to be the case here as far as the CFS goes. When we take a look at the CANCIPS model for November, December, and January, pretty similar here. above average anomalous rainfall, snowfall for California and Nevada, above average rainfall, snowfall perhaps for the southeastern US. But very similar here with what the CFS showed, below average here for the Pacific Northwest and the upper Midwest and the Great Lakes for January through March of 2024. Well, that's going to sum it up for today's detailed El Nino update for Monday, June the 12th, 2023. Have a fantastic rest of your Monday, folks. I hope this was very helpful. If it was, please consider subscribing and please share this. You got to share this with a lot of your family, with a lot of your friends. Get the word out to these people about this El Nino developing, and also leave a comment in the section below and hit that like button if you did enjoy today's update. That is going to do it. I will be back with you more tomorrow with another detailed Atlantic hurricane forecast and discussion.
People like you keep us